Assalamualaikum warahmatullahi wabarakatuh, and greeting to all my examiners. My name is Alya Aina binti Muhammad Azami, and today I will be presenting to you about my final year project, which is Biochemical Methane Potential of Mixed Solid Waste in Landfill. So first, I will be explaining about the first part, which is introduction. I will explain about the research background of this study. So as said by Zizeng 2024 in his article, municipal solid waste disposal has become a major challenge in both developed and developing countries. So it is a global problem. Thus, the environmental friendly and sustainable waste management strategies are needed to save our environment. So when this municipal solid waste disposal has disposed to the landfill, it will contribute to methane gas. So the methane from landfill contributes significantly to climate change, says by the Washington DC 2023 in their article. So by assessing the biochemical methane potential of waste, help us to understand the waste biodegradability, design effective gas collection and recovery systems in landfill. Moving on to the second part, which is the problem statement of this study. The first problem statement is Malaysia has become the waste management crisis. Why it is say so? It is because methane is one of the sources of main greenhouse gases that's found in landfill. So due to Malaysian higher waste generation than recycling rate, waste management is a major issue there. And then, according to local environmental experts, if waste reduction initiatives are not implemented, there would be nothing left by the year of 2050. So that is why it has become the problem statements of this study. The next problem statement is having a challenge of studying landfill methane potential. So why it is say so? It is because the landfill have significant potential to produce the methane in the landfill, but there is a lack of comprehensive knowledge and optimization technique for conducting biochemical methane potential by using the waste from the landfill. So one of it is because the heterogeneity of landfill content. The waste items from the landfill are generally diverse in nature and have a different composition. So due to the lack of study, it is difficult to set up the consistent conditions for researching biochemical methane potential, since different waste kind release different quantities of methane and break down at different rates. And the other one, conducting measurement of methane emission through field site measurement can be costly in terms of equipment, sampling and analysis. There are three main objectives in this study that I want to achieve, which is the first one, to determine the characterization of solid waste composition represent in Selangor's landfill. The second objective is to determine the methane generation potential of waste in Selangor landfill. And lastly, to determine which kinetic study is fit well with experimental results. There are three significance of study, which is the first one, can optimize methane production. It is because understanding the BMP helps optimizing methane generation from waste during anaerobic digestion that will allows us to identify the waste composition that maximize the methane output. The second one, it can be renewable energy production, because BMP research provide insight into the potential for generating clean and sustainable energy from mixed solid waste that will contribute to a more sustainable future. And the last significance of study, it can improve the waste management. It is because BMP findings are crucial for developing efficient waste treatment and disposal system. This system will prioritize resource recovery like methane and minimize the environmental impact. I will be discuss about the review of literature that consists of 3 points in this study, which is the first one, solid waste management and landfill. The solid waste management and landfill have become the global challenge of municipal solid waste. The municipal solid waste include residential, commercial, industrial and institutional waste. The global waste generation is projected to increase by 70% by the year of 2015 due to the urbanization and population growth, says by the Washington 2018. And then the previous researcher by Hitaraki by the year of 2007, he found that open dumps were a common waste disposal method, but have detrimental environmental impact such as greenhouse gases, contaminated water, and harmful to ecosystem. So, the sanitary landfills with linears and gas collection system were developed as an alternative to open dumps. The landfill gas, such as primary methane, is either used for energy or flared off. The landfill taps to leachate collection system that will minimize the environmental impact, and the biocover with metro ponds and plant further reduce methane emissions and manage to the leachate infiltration. Next point for the review of literature is the history of biochemical methane potential. So to start, anaerobic digestion process is a process that uses bacteria to break down the organic waste and generate biogas, mainly methane, for energy that consists of 4 stages, which is hydrolysis, acidogenesis, acetogenesis, and metagenesis. each involve different bacteria communities. So anaerobic digestion system design and operation require careful consideration of waste properties like biodegradability and potential inhibitory effects. The biochemical methane potential tests are a common method to assess the waste biodegradability for effective anaerobic digestion implementation. Biochemical methane potential results may not directly translate to full scale of anaerobic digestion operations due to difference in reactor design and continuous operation. Because biochemical methane potential tests may not fully capture complex interaction like antagonism or synergism between different waste components during the digestion. So the goal of this research is to clarify on this matter. So the last part that I will be discussing in literature review is the factors affecting anaerobic digestion process. That consists of 3 factors, which is the first one, temperature. So there are 4 main temperature ranges for anaerobic digestion microbe, which is the first one, phycrophilic, that range from 5 to 25 Celsius. It is the lowest temperature bacteria with minimal activities in anaerobic digestion. The second one is mesophilic, which is 30 to 35 Celsius. It is the most common operating range, offering a balance between digestion rate and operational cost. The third one is thermophilic, which is the 50 to 60 Celsius. It is the higher digestion rate but required more energy input to maintain the temperature. And lastly, it is hypothermophilic, which is the range more than 65 Celsius. It is less common in anaerobic digestion due to the limited microbial communities and potential instability. Minimum temperature for methane production is typically kept within the mesophilic conditions, ranging between 35 Celsius and 37 Celsius. Next factors is pH. So the optimal pH for maximum methane yield is by maintaining a pH range level from 6.5 to 7.5. It is crucial for achieving the highest methane production. It is said by the researcher of Zhang and others by the year of 2004. The last factor is size. The biochemical methane potential test should use practical particle size that minimize the alteration of the waste through characteristic. The common particle size used in BMP tests range from less than 1 mm to less than 50 mm, with 10 mm and 20 mm being most frequent. The methodology, we need to follow some steps, which is the first one, collect the sample in a landfill and divert it into 2 different samples with 2 different composition, which is the first one is consists of 45% of food waste, 8% of garden, 8% of paper, 18% of plastic, 8% of diapers, 8% of textile, and 8% of inorganic. This consists of 7 substrates, and the other sample is fairly mixed from the sample before. As for the inoculum, I take the sewage at Chapsulary UiTM Shah Alam. After collecting the sample and the inoculum, the first one I have to do is analytical method, which is characterization for moisture content, total solid, volatile solid, pH, and CHNOS analyzer. One is BMP experimental test. As you guys can see that I have listed what I have been using, which is I use serum bottle 250 ml, the working volume of 70%, and others. And then how to maintain the measurement, I use GCFID instruments in Block A, Fakulty Sains Gunaan, and frequency that I take for the methane is 3 times per week. In the result, I interpret it. And then with the result, I also do a kinetic model, which is first order kinetic model and modified Gompertz model. Next, for the result and discussion. This table shows the characteristics of the substrate, which follow the first objective to determine the characterization of solid waste composition represents in Selangor's landfill. So as for the moisture content, we can see based on this table, the Shah Alam composition exhibit a higher moisture content compared to the fairly mixed because it contains 45% of food waste. It inherits water content of food waste. And then for the total solid, the total solid content lower in Shah Alam mixed composition with 45% of food waste compared to the fairly mixed that only have 15% of food waste due to the amount of dry material remain after the water has been removed. It is said by Hamilton and Zhang by the year of 2020 in their article, the total solid represent dry weight. Total solid refers to the material remain after remove moisturized from a sample. So that is why the Shah Alam mixed composition have lower total solid compared to fairly mixed. And the next one is volatile solid. The volatile solid is higher in Shah Alam composition compared to the fairly mixed. As mentioned earlier, high moisture content means larger proportion of the sample is water, leaving a smaller amount of total solid. The proportion of volatile solid might be relatively higher compared to a sample with a higher total solid content, which contain less water and potentially more inorganic material. Next, for the pH, both samples are suitable for anaerobic digestion because the pH is closer to 7.0. And for the CN ratio, the Shah Alam mix composition have lower CN ratio compared to the fairly mix of Shah Alam composition. It is because the food waste in Shah Alam composition is rich in carbohydrate, proteins and fats, and all contributing to significantly overall carbon content. While food waste does contain some nitrogen, it's typically much lower than the carbon content. So with a high proportion of food waste, 45%, the overall nitrogen content in Shah Alam sample composition might not increase compared to the carbon, so it does have lower CN ratio. This is the graph for cumulative methane production for experimental BMP. This follows the second objective, which to determine methane generation potential of solid waste represents in Selangor's landfill. As we can see on this graph, the orange line represents the Shah Alam composition, which Shah Alam mixed composition have higher cumulative methane generation compared to the fairly mixed, which the blue line color. High amount of percentage of food waste is the main contributor why it is high. It's generally rich in organic matter, so these organic matter are readily biodegradable by microbes in anaerobic digestion, ultimately produce higher methane. So, if we can look on this graph, there are three stages, which is the first one, hydrolysis and acidogenolysis. It is known as lag phase from day 0 to 20. And the second stage is acetogenesis, which is a transition phase. So we can see from day 20 to 30. And then the last phase is metagenesis. It is the exponential growth phase from day 35 to day 44. Next, this table shows the results of kinetic study between the first order kinetic model and modified Gompertz model. And this follows the third objective, which to determine which kinetic study is fit well with experimental result. So based on the data, the maximum BMP value stimulated by the modified Gompertz model was the closest to the experimental value. The modified Gompertz model best fitted the experimental methane potential with lower RMSE value. The lower RMSE value implies a higher accuracy of a regression model told by Church by the year of 2020. The previous study of Lafrata and others shows that modified Gompertz models predictions are closer to the actual experimental result. So this translates to lower percentage error and high R-squared values. So, this graph shows the cumulative experimental and predicted biochemical methane potential values fitting curve by using the experimental data using first order kinetic model for Shah Alam mixed composition and fairly mix of Shah Alam composition. The first order kinetic model assumes a constant rate of biodegradation which might not be entirely accurate because the actual biodegradation process might have a slower initial phase, lag phase, and not captured by the model. It is not captured by the first order kinetic model. So this could be explained by the steeper initial slope of the predicted curve, as you guys can see, compared to the experimental data. So a more complex breakdown pattern that assumed by the model, the rate of biodegradation might slow down gradually as more easily degradable components are depleted, leading to less linear increase in methane production over time. And lastly, this is graph for modified Gompertz model with it is cumulative experimental and predicted BMP values fitting curve by using data of modified Gompertz model for Shah Alam mixed composition and fairly mixed Shah Alam composition. So the predicted values of modified Gompertz model generally follow the trend of experimental data points that are more closely compared to the first order kinetic model. So this suggests that the modified Gompertz model might be a better fit for representing the methane production pattern. And the modified Gompertz model incorporates a lag phase, which is likely reflected to the initial slow rise of the predicted curve. So this lag phase is often observed in biological processes as microbes adapt to the new environment and degradation starts.